Okay, let's dive right into this explainer. We're going to completely shatter the myth that allow listing an IP address is just some simple one-size-fits-all task for system administrators. Look, if you manage networks, you know exactly what I'm talking about. A user asks for access, they hand you an IP, you punch it in, and absolutely nothing works. Cue the 2 a.m. headache, right? Well, today, we're breaking down exactly why that happens and, more importantly, how to fix it across the major cloud platforms.
Here's our game plan for today. 1. The allow listing myth. 2. AWS quirks. 3. Azure NSGs. 4. GCP VPC firewalls. And 5. The troubleshooting checklist.
Section 1. The allow listing myth. Let's look at why rules fail. So, picture this. You get a ticket, you do exactly what's asked, but the connection still breaks. Why? You've clearly entered the exact IP the user gave you, right? You look at your firewall, the rule is totally active, there are 0 typos, but the packets, they're still dropping. The answer almost always comes down to where the filtering is actually taking place versus where the user actually thinks they are. It's like a giant miscommunication.
And here is our usual suspect. You've got your private RFC 1918 IPs, like your standard 192.168.1.50 local network address. A user will typically check their local machine, see this private IP, and send it right over to you. But if that traffic crosses the internet, Network Address Translation, or NAT, rewrites that private address right at the edge, meaning your upstream or cloud firewall sees a completely different public IP. If you allow list that internal laptop address on a public-facing cloud firewall, there's no way it's going to match. The golden rule here, you absolutely must identify the real source IP seen by the filtering device.
Moving right along to Section 2, AWS quirks. We're talking allow-only rules.
What's really fascinating here is that AWS uses a strict allow-only model. You literally cannot write an explicit deny rule in a standard AWS security group. By default, everything inbound is denied until you explicitly say, yes, come in. Because of this, AWS explicitly warns against using the anywhere IPv4 setting, that 0.0.0.0/0, unless it is absolutely necessary. Doing that is like taking the front door off its hinges. You're opening the network to the entire internet, which completely defeats the purpose of an allow list.
So, when you're locking down access to a single host in AWS, you've got to use CIDR notation to define that exact IP address. A single IPv4 host is written with a /32 at the end. So, for example, 203.0.113.1/32. This is literally the tightest possible net you can cast. It tells the AWS Security Group to authorize only that specific exact IP address and absolutely nothing else. All right, Section 3, Azure NSGs. Here we introduce allow, deny, and priority.
Unlike AWS, Azure evaluates both allow and deny rules. Now, this gives you way more flexibility, but also more complexity. And you have to be super careful about attachment scopes. In Azure, these network security groups are attached either to a specific network interface card, a NIC, or to an entire subnet. So, think about it. If your allow rule is attached to the subnet, but a totally different NSG attached to the specific VM's NIC is blocking the traffic, your connection is going to fail.
The most crucial thing to remember here is priority. In Azure, rules are processed in priority order, and a lower number, like 100, actually has a higher priority than 200. And here's the kicker. Azure stops processing the very second it hits the first matching rule. So let's say you have a broad deny all rule sitting at priority 150, and you put your highly specific IP allow rule at priority 200, well, Azure will hit that deny rule, drop the traffic, and completely ignore your newly minted allow rule.
Section 4. GCP VPC Firewalls. Let's look at VPC level rules.
Now, GCP behaves very similarly to Azure. It supports both allow and deny actions, and it also relies on those lower numbers for higher priority. However, there's a distinct difference in scope. These rules are applied at the Virtual Private Cloud, or VPC, perimeter. When you're creating an ingress IPv4 restriction in Google Cloud, you set your source filter directly to the required CIDR blocks, keeping your workloads securely locked down at the broader network edge.
I love looking at this side by side because it perfectly sums up the unique traits of each platform. AWS is kind of the outlier, with its allow-only model scoped to the security group. Azure and GCP, they both utilize allow and deny rules based on that lower number wins priority system, but they totally diverge on scope. Azure targets subnets and NICs, while GCP targets the entire VPC. Honestly, understanding how rule evaluation differs depending on where your workload lives is half the battle won.
Which brings us to Section 5, the troubleshooting checklist. Fixing those broken rules.
Okay, when a rule looks perfectly right but still fails, don't panic. Just aggressively run through this toolkit. Number 1, confirm the real IP. Remember our NAT discussion from earlier? 2, check your exact destination port and protocols. Port 22 is totally useless if the service expects UDP. 3, verify your attachment scope. Is it on the right NIC, subnet, or VPC? 4, double-check those priority orders in Azure and GCP. 5, remember that an allow rule doesn't magically publish a private host. You might still need port forwarding or NAT. 6, verify IP stability, especially if your user is on a dynamic DHCP address. And finally, number 7, in Azure, NSG changes usually only affect new connections, so an already established flow might literally be masking your fix.
As we wrap up this explainer, let's anchor ourselves with this core operational security mindset. The safest pattern is to identify the real source IP and whitelist only the minimum source and minimum port range required. It's absolutely crucial. Always strive for a stable source address, use that /32 CIDR notation we talked about, and wholeheartedly embrace the principle of least privilege. Narrow rules are secure rules for sure.
So I'm going to leave you with this to really think about. Are your current firewall rules actually secure? Or are you letting the complexities of NAT and multi-cloud priorities push you into taking the easy way out, relying on dangerously broad allow lists instead of tracking down that true /32 IP? Take a hard look at your perimeter today. Thanks so much for joining me on this explainer.